Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Quad University of Science and Technology. Today we will take lecture number 29 of the subject of software engineering, in which we are going to discuss types of software metrics and defect removal efficiency metrics in software engineering. Dear students, we have already discussed the software process metrics, so we are continuing our lecture from the previous lectures. This is the discussion agenda. We have the process metrics and the software process improvement. Here we will discuss how a process matrix can work for the improvement of the software development lifecycle model. Then we have factors affecting the software quality. That means that here we will discuss different factors, different essentials, attributes which are required to enhance the quality of the software. And then we have the project metrics. Here we will discuss different types of the project metrics. And at the end we have the product metrics. Here we will discuss different product metrics along with their examples. Now, the process metrics and software process improvement. Dear students, as we already explained the process metrics in the previous lectures, that the metrics which improve the life cycle model or a software development process is called the process metrics. Now, the process metrics has a lot of factors or involvement in the software process improvement. Now, to improve any process, the rationale way is to measure the specific attributes of the process. So, the first point is to measure the particular attributes which is relevant to the process. For example, the attributes is number of people required in the process. Similarly, the time required to complete the process or a particular activity in the process. These are certain attributes. Similarly, the resources required to complete a process is also a part of the attributes of the process. Then, after measuring the specific attributes of the process, then we have to derive the meaningful metrics from these attributes. Meaningful metrics means that we have to apply a certain formulas or certain equations which are standard software matrices, and these are used to measure the software attributes. Now use these metrics to provide indicators. Now, using these metrics, we need to provide indicators. Indicators are certain factors or certain results which are in fact obtained when a particular matrix is provided. So, the indicators represents that which areas should be improved and what will be their results. The indicators lead to a strategy for the improvement. So indicators are in fact certain causes or certain results which helps us to improve the software process. For example, if we increases the training of our staff members, then automatically the productivity of the programmers will be improved. So these are the indicators for the improvements of the processes. Now, there we are discussing an example of a process matrix. So, for example, if we have to improve the quality of a software process or a quality of a phase of a software process, that may be either repeatable or managed. The repeatable means that when a particular activity is repeated over time, then it is in fact improved. And when it is repeated, it gives us better results as compared to the previous activity. And managed, the process means that a good managerial experience and education is required to perform the process. So, if a process is repeatable and managed, so then the quality of the software process models for the product will be of a high standard. Now, strategic and long-term for the long-term and statistical software process improvement is used. So SSPI is a methodology or some standards which are used for the long-term and strategic improvement of the software process. Now, if there are certain errors in a programming which arises, then error categorization and analysis is performed. So by error categorization means that we first of all identify different errors and then we categorize these errors for certain classification and then we analyze the error. So here analysis of the errors are performed. Analysis of the errors means that we identify the consequences of these errors on the product and also we identify the resources required to remove or correct these errors. So basically error categorization and analysis mean that all errors and defects are categorized by origin. By origin it means that from the source where these errors occur. So basically categorization means different types of errors and their sources from where these errors are emerging. The cost to correct each errors and defects is also recorded. So here we also required different costs required to correct or to remove these errors and also the defects which are occurring in the product. There are two terms used here, the errors and the defects. The errors means those problems or those issues that if this issue arises then the program will not be executed. And defects means that the program will be executed correctly but when we perform some input output and other operations here then the program will give us wrong results. These are called the defects. So here after categorization we will identify different costs which includes the hardware, software cost and the personnel cost, means that resources required to complete or correct the error and also we will correct the defects. So all these things will be recorded. By recorded means that we will document all these informations. The number of errors and defects in each category is computed. Here we will compute the number of errors, means that we will count here the errors and defects and in each category is in fact counted. Data is analyzed to find categories that result in the highest cost to organization. So means that here we will identify different highest costs that will occur to correct these errors and defects. So here we will identify these costs and we will document these costs in the form of the data. Next we will plan which will be used to modify the process. So here we will create or develop different plans that will be used to modify the process. Means that if in the future project if these errors and defects are identified or they will occur, then we have advanced strategy or the planning to handle these issues. Now for this purpose we use defect removal efficiency matrix. So DRE or defect removal efficiency matrix. Defect removal efficiency is a matrix which shows the relationship between errors E and defects D. So again I am explaining that error is a certain issues through which if these issues occurs then the program will not be executed, and this usually arises during the development time or in the programming phase. And defects are those issues or those problems which will gives us wrong results. Means that if the program is executed it will compile and run correctly, but if a user will perform certain operation then the operation will gives us wrong result or they will not be completed. So these are called defects. So if the ideal value of DRE is 1, that means that the program is of a high quality. So means that if it gives us 1 as the output, the formula of DRE, then it means that program is of high standard. Now, what is DRE? DRE is the defect removal efficiency, and it is the number of defects resolved by the development team divided by total number of defects at the moment of the measurement. The ideal value is 1 because if E divided by E plus T means if there are no defects, then E will be divided by E. So that means it will give us 1. So which means which is the ideal value of DRE. Now DRE is an equation in which we have number of defects resolved by the development team divided by total number of defects at the moment of the measurement. And so the DRE is equal to E divided by E plus T. So E represents the errors and D represents the defects. If there are 100 defects found during quality assurance testing stage and 84 defects were resolved by the development team at the moment of the measurement, that means that DRE would be calculated as 84 divided by 100. So total defects are 100 and 84 defects were resolved by the development team. That means 84 were the errors and total defects with the errors are 100. So that's why it gives us 84% the value of DRE. So if the value is smaller, that means that 1, so it will be the ideal. If values becomes larger, for example 84, 85 up to 100%, that means that the program is full of the error. Now, factors affecting software quality. There are different factors which affects the software quality. It includes product, people and technology, and these three are the parts of the processes. The process is in fact carried out by the people for the development of the product using the technology. Now, people have different customer characteristics, means that customers have different types of preferences. For example, customer wants high quality software products in less amount of time and within a reasonable budget. Similarly, the process also contains the development environment. Development environment means that the process used to develop the software and the technology and resources required to complete the project. And similarly, the business conditions means that the software should be developed within the given business values are within the budget. So if the budget exceeds then the benefits of the projects, then it means that the projects will be failed, otherwise it will be a successful project. So these are multiple factors which affects the quality of the software. Now, how we can measure the effectiveness of a software process? If the software is very much effective, then it means that it will give us a good product. If a software is not effective, ineffective, then it means that the result will be of the wrong product. So we measure the effectiveness of software indirectly. We cannot measure it directly. So we use a certain matrix based on the outcomes that can be derived from the process, and the outcome includes errors uncovered before release of the software. So this is one of the output of the process, that all the errors identified before the release of the software to the customer. And secondly, defects delivered to and reported by the end user. So after the delivery of the software to the end users gives us different sort of the list of the defects that he or she has identified while using the software. And the work products delivered, that means the productivity, how many products are the programs or the softwares have been completed by the particular organization, and the organization will be the developing organization. And the human efforts required to complete the project, which includes different programmers, analysts, designers, and software quality assurance personnel, and similarly project manager. So all these people who are responsible to develop the software. The calendar time required to complete the project. This includes the schedule or the schedule of the softwares to be completed, the conformance to the schedule, and then the schedule which we are going to achieve should be very much realistic. That means that the schedule should be realistic as well as it must be achievable. The next types of risk projects are metrics is the second types of metrics. So the project metrics are the measurement of the software projects and are used to monitor and control the project. So the project metrics is a certain metrics which we derive from the project directly. So it includes different sort of the matrices which controls and monitors the project. So these metrics enable a software project manager to minimize the development time by making the adjustment necessary to avoid delays and potential problems and risks. So the project matrix is a certain matrix which is used by the project manager to minimize the development time. So how he or she can minimize the development time? So by making adjustment necessary to avoid delays and potential problems and risks. So all the risks and problems that are identified in the project that must be resolved to minimize the development time. Similarly, assesses the product quality on ongoing basis and modify the technical approach to improve the quality. Here, the project manager is responsible to assess product quality, and the product quality is the different quality attributes, which includes, for example, efficiency, portability, usability, reliability, understandability, and ethical requirements, etc. So the project manager assesses product quality, and also it can be modified the technical approaches to improve the quality. So all the technical approaches are used to improve different qualities. Technical approaches there means that say that the high standard quality tools for the development should be used, including high standard languages and database tools, and similarly high standard networks devices. Now, where we can use the project matrix. Project matrix is used in estimating techniques and other technical works. Different estimation techniques and technical works is measured using the project matrix, and metrics collected from the past project are used as a basis, are used as a history for which efforts and time estimates are made for the current software projects. So the project matrix precedes actual the values of the human efforts, and also it gives us the calendar time that has been used as compared to the original estimates. So basically the calendar time is the time required to complete the project, and what we have estimated originally, if the calendar time is less than the original estimation, that means that the project is going towards the right direction. Otherwise, the project may be failed. So this data is used by the project manager to monitor and control the project. Now, the project matrix having different categories, and the software project manager and software teams adopt the project workflow and technical activities. It includes different metrics such as efforts or time per software engineering task, means that different efforts is the human effort required to complete the project, or the time schedule required to complete the project for the different software engineering tasks. And errors uncovered per review hours. If there are certain errors occur, these errors are corrected and they are uncovered, means that they are identified in our review, and the review should be measured in per review hours. Similarly, schedule versus actual milestones dates are measured. That is, these are our scheduled milestones and these are actual milestones dates. Number of changes and their characteristics. If there are required certain changes in the software project, then these changes are identified and their required resources and time schedule is computed again, and their characteristics are also identified. And then at the end we have distribution of efforts on software engineering tasks. So we uniformly distribute our efforts required to complete the software engineering task. Here efforts means that the team and different peoples that are responsible to complete the project, their efforts on each and every software engineering activities. Now, product metrics are the measure of a software product at any stage of its development. Means that we can use the product metrics at any stage of the development, from the requirements to the installed systems. Requirement is the first phase, while the installed system, which is the operational phase, which is the last phase. So, product metrics may measure the complexity of software design, the size of the final program, and the number of pages of documentation produced. So here it means that different sort of the metrics including complexity of software design. So how much software is complex? Complexity of software design can be measured through the cyclomatic complexity, which is a topic in software testing. Basically these are different formulas, but complexity here means that how much the software is complicated by its functionality and by its code and design. And the size of final program, when the program will be delivered, what will be the size of the program? The size of the final program means that the final project which will be delivered to the customers, the size of the project at that time, and the number of pages for the documentation produced. During the software development, we produce different documentation. For example, software requirement specification is one of the document. Software design description is another document. Similarly, software test cases is another document. So all these documents are produced during the project. So when the product is completed, then we also measure that how many pages are produced. This also includes the complexity of the project. Types of software measure. We have two types of software measuring. One is called direct measurement and second one is the indirect measurement. Direct measurement is done or it is performed directly from the product, and it is quite easy to collect because we have already product with ourselves. So the direct metrics includes costs, means the budget, effort means the different people required to complete the project, their working hours are the working days, lines of codes, which includes all the statement of the executable statements of the program, and execution speeds means that efficiency of the program in terms of the CPU speed. Memory size means that memory required to execute the software. Defects mean difference. Logical errors are different faults in the program. So all these are measured, and indirect measurements are those measurements which are relatively difficult to obtain, and these are indirectly obtained from the process or assessed. So it includes different sort of the quality, functionalities, complexity, reliability, efficiency, and maintainability. So this measurement requires a lot of time, and these are very much difficult to access because assessing the complexity or functionality or quality, and similarly efficiency and maintainability, reliability, can be measured indirectly only. We cannot measure directly. Now dear students, this is the end of this lecture, and if you have any question you can ask through the email. My email is m.kadeem@kust.edu.pk, and also if you want to read these topics from the books, these two are the different books of software engineering which are very much renowned books. Software Engineering by Ein Sommerwald 8th edition, and Roger Pressman book of Software Engineering, A Practitioner Approach, McGraw-Hill. This is a very useful book. These two are very much easy and best books of software engineering. And also if you want to study more, you can search the IEEE research articles for the different matrices. So I hope that you have got useful ideas from these lectures, and if you have any question, I will wait for your question. I will reply your question immediately. Thank you very much.